Hey there. I'm going to talk about polyatomic ions and kind of how to do them. And before I do that, there's a really good point here, which is why are we going to learn these in an online class, especially where people are just going to often look them up. In an on-ground class, you can say, well, it's on the test and I have to memorize it. But the real reason you memorize these isn't necessarily because it's something to ask on a test. Maybe some of that is true. But you memorize it so you can recognize things. And the more you have in your brain this information like accessible, it's like a word that you know, the easier it is to just read sentences. So, if you're taking Spanish class and you have to look up every word because you never memorized any nouns, it's pretty hard to read a sentence. It takes forever. And, you can say, well, I'll just use translate, but eventually that's not going to work. And chemistry is a little bit the same way. There's the more you memorize these, kind of the easier it is to read and understand later and move on in chemistry. The more you just say, well, I'll just look up each one as I go, you never really get it inside your brain. So it's worth the trouble. And there's a couple of easy ways of memorizing this that maybe will help or not. So so a polyatomic ion is just a group of atoms that have a charge. Almost always negative. There's like one exception to that. And so what I'm going to do is I'm going to kind of cover them in order from sort of the most common to sort of the least common. So these top ones are the ones you're going to see over and over again in biology classes, physiology classes, everything. So, and those are the 8s. And 8 means they end in ATE. And so what I'm going to do is I'm going to draw a little periodic table here. Just that kind of end row. I'm going to put chlorine, sulfur, phosphorus, silicon. And I'm going to draw a bunch of compounds, and they're all going to be the 8s. So this one doesn't have anything, and there is actually no compound fluorine with oxygen, so I'll cross those off. And some of these you see in your textbooks, and some of them you actually don't. Now, for instance, this silicate one here, the end, it's not very common. Okay, so all of these have names that end in ATE. There's one exception, which is historical, but start here at the bottom. These will be the phosphate. I'll edit out me writing on a lot of these. So in green are all the names of these things. If you notice down here, perchlorate, that's the exception to the rule. I'll get into that in just a second. So how do I memorize these? I get these from the periodic table. B, C, N, O, F. Ooh, I forgot to write boron, but we usually don't cover him. Cn, silicate. Usually silicate is not covered in a lot of textbooks, and neither is the borate. But nitrates, phosphates, sulfates, and carbonates are incredibly common. They're all over biology. They're everywhere. What's a good way to memorize them? Look for a pattern first. Look at the red numbers, the charges, and you notice they go 1, 2, 3, 4 as you move to the left. If you go up 1, they're 1, 2, and you can make a prediction about what borate's going to be. We'll do that in a second. If you look on this first row, first period, you see that the numbers of oxygens is 3 oxygens, and if we go down 1, we have 4 oxygens. So how do you memorize that? Well, think to yourself, if I was to go from nitrogen to phosphorus and I add 1 oxide, and oxide is oxygen 2 minus, you can kind of think about, if you add an oxygen 2 minus, you get an extra oxygen, so it's a 4. You change the end of the P, like by magic, and then you add a 2 minus, and then you get phosphate. So if you can kind of memorize this little pattern, maybe pick one of them to memorize, like nitrate, NO3 minus. And then you can remember as I move across the periodic table on that row, number of oxygens stays the same. If I drop down when I add one oxygen to get all those compounds. Those are the 8s. If I asked you, what do you think boron's going to be? So if you don't memorize that one, BO, you probably guess 3 oxygens because that stays constant, and the charge would be -3, and you'd be correct. So that's a pretty uncommon one. You don't see it in a lot of textbooks, but there you go. The weird one here is perchlorate. I'll come back to that in just a second. It's got a goofball name. The word per, though, you'll see this abbreviation in chemistry, or used differently in chemistry. Per means around. Like the perimeter of a circle is around the circle. Perambulate is to go around, walk in circles. Perchlorate is you've encircled it with another oxygen. So the word per in chemistry means add an oxygen to whatever comes next. So you add an oxygen to the chlorate and you get perchlorate. That name is actually, I'll cover it in just a second. Okay, so if you memorize those, and those are the ones I cannot emphasize enough, definitely memorize those, because I can't test your memory on that, but that doesn't matter. They're going to really show up in biology. Okay, so the next group are the ites. And here you actually get to just sort of recycle all your knowledge. So CNOF, and if you remember, there was none of those. We do have P, sulfur, chlorine, and silicon. And before we had, NO3, now we have NO2. Before we had PO4, now we have 3. We had 4, whoops, and now we have 3. ClO3. And the charges stay the same. 1, 2, 3, 1, 2, 3, and 3. Now, okay, so I've written the names now. The ites, nitrite, phosphite, sulfite, chlorate, that's the exception to the rule. Ite means take away an oxygen. But leave the charge the same. Right? Now, some of these don't exist, like carbonite. They actually mention this in the book. The Han Solo, Star Wars, carbonite, freezing. Doesn't exist in the real world. Silicite, there's no such thing. But these are the very common ones. Nitrite, phosphite, sulfite, very common things. And by the way, the word ate actually has a meaning. It's the element with oxygens, with the most common number of oxygens. In its most common charge. So that means if you dig up nitrogen in the world and it's combined with oxygen, it's going to be 99% of the time a nitrate. It's the most common form. Carbon, when you can breathe it out as carbon dioxide, but when it becomes part of a compound, it's almost always carbonate. Very rarely anything else. So that's the most common form, was the ate. The ite was you just take away a hydrogen. So chlorate's the weird one, and go back to this. So we have ClO4, ClO3 minus, that's perchlorate, and that's your chlorate. Well, what would you think would happen if I took away an oxygen? Now, if you think about it, if I took away an oxygen before, it became an ite, and you'd be correct. So my understanding of the history of this is that chlorate was the first one discovered. For whatever reason, they don't really naturally occur very often, And so people discovered this thing. They made compounds called potassium chlorates, which are used for rocket fuel and stuff, fireworks. They made potassium chlorate. They thought, well, this is the most common form, or the most stable form. And then it turned out that the perchlorate is, I think, more stable. So chlorate got named first. Then they came up with perchlorate, like later because of history. But at that point, they didn't want to change it to make it consistent. So we got stuck with it. I'm not 100% sure if that's true, but that's my understanding of the history. If you remove an oxygen, you get chlorite. Now, it turns out that they discovered that there's another form of chlorine plus oxygen, and that is you take away one more oxygen. And so they used another word, hypochlorite. And hypo, if you think of a hypodermic needle, it goes below your skin, below the dermis. Hypothesis, below a thesis. Hypochlorite, below the chlorite. And of course, if you take away one last oxygen, you get back to chloride, which is, that's where we started. So chlorines have kind of a weird sequence. Yeah. By the way, you also get a whole bunch more from this if you want to, and I'm sure you do. Right? If I switch down to Br for bromine, you get perbromate. If I switch to BrO3, you get bromate. If I went to IO4, you get iodate. And you get sort of odd words like that. Hypoiodite, hypobromite, bromate, bromite. All these kind of ones. So you can kind of go on and make a whole big grid of these things. These are fairly common in rocket fuels. These guys much less common, to be totally honest. You don't see a lot of them. Okay. So these guys, though, really important. The nitrites and the nitrates both occur a lot in biology, so you definitely want to know those. Okay, so now there's some more to memorize, and one or two, frankly, not to memorize. But okay. So on this top corner, top left, I got 3 ways of writing the same thing, and these are all called hydroxide. Hydro for water. Boy, that's some sad. I'm sure I'll edit that mistake out. Okay, so hydroxide, water, negative. So hydro is water, ide is negative, so it's the negative of water. Hydroxide. All 3 ways are common. I write OH minus just because that's kind of the way I say it. The book will often write the second way that's common. I've seen literally all 3 done, so they're all fine. They all mean the same thing. Really common. The one on the right are 5 different ways of writing the same thing, and you really kind of have to learn to recognize it. So all of these are called acetate. And this compound, if you add a hydrogen to it, looks like that. And that's acetic acid. Acetic acid is vinegar. It's the Latin word acetus, I believe, is the Latin word for vinegar. So it's vinegar acid. If you take a hydrogen away from it, you get the 8 form of it, the negatively charged form. So that word 8 always means it's negatively charged. The top way is the most common way of writing it in kind of freshman books or whatever, beginner. The second way is the cartoon version, which I kind of like because I think it's easy to remember a picture, and I think it's a lot harder to remember a series of letters and numbers. So to me, this little cartoon, I think, has a shape. It's a triangle. There's 2 sticks. There's hydrogens on one side. It's just a picture. All of the other methods are a little hard to remember. In your bio class, you may have heard of acetyl coenzyme A. You'll see acetyl groups all over the place. They often abbreviate it just AC because it's so common. Okay, so anyway, all sorts of different ways of writing it, very similar. They're all acetates. Okay. Jump back to the left here. This one's actually really easy, but people don't always recognize it. If you go back up to or maybe you've memorized it, SO4 2- was sulfate. Now, let's say you didn't know what this thing was called and you just had to guess and you said hydrogen sulfate, you'd be correct. That's pretty good. So chemists have decided to call this fellow hydrogen, like hydrogen plus 1, and sulfate. And the two words are separated with a space. We got H plus and the SO4 2-. You glue them together, you get HSO4. Seems easy. I like it. Really nice. That's what chemistry people do. Hanging on in biology classes and sort of older textbooks and things like that. And this is a bit kind of bizarre, but people have generally tried to get rid of the word bisulfates and bicarbonates, but they just keep hanging around in other literature, especially in biology. Not sure why. But this word bi, you would assume, like a logical person, meant two. It doesn't. Di is what we use in chemistry for two, and bi means it takes twice as many of them to equal a regular sulfate. And that's the original, actually the original root of the word was bisulfate, because bis means a pair in, I think, Latin. No, Greek, in Greek. So it means like a pair of things in Greek. Anyway, not important. So they used to call it bis, and then it got changed to bi. That took off. They tried to change it to hydrogen sulfate. That's what we call it, but it's often called bisulfate. You don't have to use bisulfate, but if you do use it, I'll recognize it and say that it's good. Next one down, take a guess. Probably right. You're going to know it. Hydrogen carbonate. But, you know, this is fairly commonly known as bicarbonate. So if you've ever used baking soda in your kitchen to clean things, you've heard of it as bicarbonate. So sodium bicarbonate, really common compound. Yeah, it meant that there's twice as many of those carbonates to equal a cation than the regular carbonate. So, again, just always use this one, and you're using proper chemistry language. Next one down is a little unusual. What's unusual about it? It's positively charged. It's the only one. So this is ammonium. IUM means positively charged in chemistry talk. Most of the elements end in IUM because they're metals like aluminum or aluminium and chromium, things like that. But not everyone does. They're not always, the namers weren't always super consistent. By the way, NH3 is ammonia. And that's the name of the freed gas. So ammonia is a gas at room temperature and stuff, and ammonium is the compound. That's a very common compound, by the way, really common in biology. You know, there are some weird ones too, and normally, to be totally honest, I never tell people to memorize this. Chem 1A, whatever class. I say, don't bother. However, this one's kind of weird. This is permanganate. Mn is manganese and G is magnesium. Tricky there. And here, this one is dichromate. Now, first question is, if it's dichromate, what's chromate? There's no chromate. There's no chromate ion that you commonly use. And if it's permanganate, there must be manganate, right? No, there's no manganate. It's just permanganate. So right off the bat, that's annoying because they're the names don't even make sense, like based on the rules. Secondly, and this can be really tricky, you know, this compound, which is kind of a purple oxidizing compound, used to be really common in chem labs, a little less so now, but this fellow would be called potassium permanganate. And so much trouble in this because if you don't recognize MnO4 as a polyatomic, like you haven't memorized that one, invariably people start thinking like this is manganese +7 and this must be potassium +1 and each oxygen is -2. and they come up with all sorts of strange things, you know, and then they start calling it potassium manganese 7 oxide and all sorts of crazy stuff. So those two, you know, honestly, I say don't memorize those. You don't run into them nearly as much as they used to in the old days. Chromate oxidizing used to be very common. That's much less common because the metal's toxic and waste disposal is kind of expensive. However, the rest of these definitely need to know. There's more than this. There's oh so many more than this. I could literally go on and cover pages of polyatomic ions. Unless you're doing this for real, don't learn them. However, that top stack, definitely learn them. So, I know it's a long talk on a fairly simple subject, but thanks for sticking with me, and thanks. Have a good day.